Dear students, this lecture is for class 10, subject mathematics, and the topic is arithmetic progression. In this lecture, we will discuss what is a sequence, then we will move to progression, what is a progression. After that, we will discuss what is an arithmetic progression, which we generally abbreviate as AP. Then we will go to the general form of an AP. After that, we will go for an exercise on this AP. How can you determine the nth term, the general term, and how can you define the number of terms in an arithmetic progression. After that, we will derive a formula how to determine the sum of n terms of an AP, of an arithmetic progression. First, we will start with this sequence. What is this sequence? Let me start here. Let me write a few numbers here, a collection of numbers. Let's start with this 1. Then I will write 5, 9 and 30. Next group of numbers, we will write it like 1 by 3, 1 by 9, then 1 by 27. Let's have a look on these numbers. 1, 5, 9 and 30. देखिए आप यहाँ पे I can get this 5 by adding 4 to the previous term of this 5. That means I will add 4. Now it is easy for us to get the next term of this 17. That means you have to add 4 to this 17 to get 21. So we can observe here that these numbers form a particular sequence following a particular pattern. That means these numbers form a sequence. Similarly, look at these numbers. 1 by 3, then 1 by 9, then 1 by 27. Following the same rule, we will do one thing. यहाँ पे the next term of this 1 by 27, you have to keep one thing in mind. We are dividing the preceding term by 3. यहाँ पे जो आपकी next term आएगी उसकी जो preceding term बन रही है that is 1 by 27. Simply you have to do one thing. You have to divide this 1 by 27 by 3 to get the next term in this group of numbers. That is 27 into 3 is 81. That means again these numbers are following a definite pattern. So we can say this set of numbers, it is a the sequence like this. a sequence, a set of numbers arranged in a definite pattern according to some rule or rules. Look here, the numbers now clearly, this collection of numbers, it is a sequence, this collection of numbers, it is a sequence. Now look at these numbers. Usually denoted by A1, A2, A3, so on. Similarly, T1, T2, T3 and so on. Look at these subscriptions 1, 2, 3. These denote the position of a term. A1 means the first term of the sequence. Then you have here A2, it denotes the second term of the sequence. Similarly, A3 denotes the third term. And T1 denotes, this one denotes the position. So T1 is the first term, T2 is the second term, and T3 is the third term. It is like this. Now let's have a look on this progression. What is this progression? Now let's have a look on the definition of this progression. Simply we can define a progression like if the terms of a sequence follow a definite pattern or can be described by an explicit formula. It is a progression. For example, 1, 3, 5, 7. Look here, you can get any term of this sequence by adding 2 to the preceding term. For example, if you want to get the second term, you have to add 2 to this one, the preceding term of this one. That means it sums up to 3. Similarly, you can get here 5. You have to add 2 to the preceding term. That means getting 5. Similarly, you can get the 7 by adding 2 to this 5. Right? For example, in the sequence of odd numbers, the nth term can be obtained by the formula 2n minus 1, where this n belongs to set of natural numbers. Writing the odd numbers 1, 3, 5, then 7, then 9, then 11, then 13, then 15, 17. For example, you want to get the fifth odd number by this formula. Simply you have to do one thing. आपको क्या करना है? आपको n को replace करना है by 5 to get the fifth odd number. So put n equal to 5. Using this n equal to 5 in this formula to get the fifth odd number. It gives us 2 replacing n by 5 minus 1. 2 5s are 10 minus 1, it is 9. Look here, it is first, second, third, fourth and fifth odd number is 9. That means this formula works here. So it is a progression. Is it clear? Now we will move to arithmetic. 6 minus 4, you are getting 2. 8 minus 6, you are getting 2. Similarly, another one, 5, 7, 9, 11. Again a sequence, because easy for us to get the next term of the sequence. Adding 2 to each term, you are getting the following term. Look here, 7 minus 5 is equal to 2. 9 minus 7 equals to 11 minus 9 equals to, so a sequence. And we can say these sequences are arithmetic progression. Now how can you define what is an arithmetic progression? Arithmetic progression is simply a sequence in which the difference of any term with its preceding term is constant. For example, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. So it is an AP. The difference of any term with its previous term is always constant. This difference is called the common difference, and we usually denote this common difference by D. Write down the definition of this AP, a sequence of terms is called an arithmetic progression if the difference of any term with its preceding term is always constant. In the AP are called terms because it is a sequence. We generally denote the terms of a sequence, terms of an arithmetic progression by T1, T2, T3. If it is a finite arithmetic, if it is a finite sequence, then we can write it is an term exists or the lost term exists, or you can write it like A1, A2, A3, so on, AN. So it is an arithmetic progression, simply a sequence in which the difference of any term with its previous Look here, following the definition of an arithmetic progression, we can write T2 minus T1 is equal to D. This will clearly imply that T2 is equal to actually T1 plus D when you transpose this minus T1. Similarly, T3 minus T2 is equal to D. Following the definition, because the common difference is same, everywhere implies T3 can be written as T2 plus D. Similarly, T4 minus T3, it is again D. So this gives us T4 is equal to T3 plus D. Now look here, can I write this Tn, the nth term of this AP as Tn minus 1 plus D? Yes, definitely. Look here, let's have a look on this statement. This is T4, the fourth term. I have written this as T3 plus D. Similarly, T3 is equal to T2 plus D. T2 is equal to T1 plus D. Look at these three statements. Following the pattern, how can you write this Tn is actually equal to Tn minus 1 plus D? Can I write this one as T2 as T2 minus 1 plus D? Because T2 minus 1 is again 1. So you are getting here T1 plus D. Similarly, look here, T3 is equal to, can I write this T2 as T3 minus 1 plus D? मैं यहाँ पे कुछ चेंज नहीं कर रहा हूं, अलबत्ता थोड़ा सा शेप को चेंज कर रहा हूं. I have written this 2 as 3 minus 1. This 3 minus 1 is equal to A and D is the common difference. So writing here. Now look here, T2, it can be written as A plus D and T3 is equal to A plus 2D. Look at the fact that T2 is equal to T1 plus D. Simply you have to replace this T1 by A as we have considered the first term of the AP as A. That means I am replacing this T1 by A, so it becomes A plus D. Similarly, T3, I have written here it as A plus 2D. Look here, T3 is actually equal to T2 plus D. Now replacing this T2 by A plus D and plus this D. So this sums up to two minus 1 into D. Look at this one. Here the coefficient of D is 1. So A plus 2 minus 1 is 1 again. That means you are getting A plus D. Similarly, following this pattern, I have written this A plus, now I have to write this 2D. 2D, I will write it like the subscript of this T minus 1. That is 3 minus 1 into D. Again you are getting 3 minus 1 is 2, A plus 2. Third term is A plus subscript minus 1. Fourth term is A plus subscript minus 1. In the same way, you can write the nth term, that is A plus subscript minus 1 into D. This forms the nth term of this AP, and we call this nth term as general term of an AP. Now we can write here the general formula Tn. Now let's have an exercise on this AP. Let's have an exercise on this AP. The given AP is 7, 11, 15 and 19. Question is like, you have to determine the common difference and the 10th term of this AP. Look here. Here, usually we denote the first term of an AP by A. So A is equal to 7. Subscript 10 minus 1, it is 90. Just like if you have to write the first term, it is A, second term is A plus D, fourth term is A plus 3D, 11th term is A plus 10D. In the same way, 10th term is A plus 9D. So A is equal to, replacing this A by 7 plus 9, and the common difference is 4. This gives us 7 plus 9 into 4 is 36. This sums up to here the 3-digit numbers. First 3-digit number is 100. Next one is first 3-digit number which is divisible by 5 is 100. Next one is 105. Then we have 110. And the last one which is divisible by 5. The 3-digit number which is divisible by 5 is 995. The last 3-digit number is 999, which is not divisible by 5. That is the reason I have not written this 999 here. The last 3-digit number which is divisible by 5 is 9, 9 and 5. Clearly, look here, the general term, the nth term or the last term this time is 995. I will simply write here an is equal to 995. Our question is, we have to determine the number of 3-digit numbers which are divisible by 5. Let me write here, let us say that let n be the number of 3-digit numbers which are divisible by 5. We know that the nth term an of an arithmetic progression is given by a plus n minus 1 into d is equal to an. I need to determine this n. A is given, the first term of this AP is given, d is given, common difference is given, an, the nth term of this AP is given. Simply you have to do one thing, replace